Problem number 10. Yes, I realize the numbering is slightly off on this study guide, but that's okay. We can adjust. Which equation matches the table below? Well, first and easiest thing is going to be to try to figure out whether or not there's a constant rate of change at all. So 2 to 0, that's a change of 2. 2 to 0 to 2, that's a change of 2. 2 to 4, that's a change of 2. So my x values are each changing by 2. 4 to 0 is 4. 0 to 4 is another 4. 4 to 16, however, that's 12. Which means we don't have a constant rate of change. That's going to knock out A and B because of both of those are in direct variation form. Y equals kx. Which means we're down to it could be C or it could be D. At this point, the easiest way for you to verify your solution is probably going to be to check some ordered pairs. If I plug -2 in for W over here, we'll get -2 times 2, which is -4, squared is 16, so that knocks that one out. Let's check just to make sure that this one works. -2 squared is 4, that's correct. 0 squared is 0. 2 squared is 4, and 4 squared is 16. So D, in fact, does match the table. Number 11. Which function matches the one in the table? Well, now I notice that all of these are in direct variation form, which means we should have a constant rate of change within our table. 4 to 6 is 2, 6 to 8 is 2, 8 to 10 is 2, 8 to 12 is 4, 4, and 4. Now my change in my y's is 4, over my change in x's is 2, which simplifies down to 2. So we should remember that our slope is now 2, and since our slope is 2, we're looking for that value in front of value in front of x to be a 2, because that's our m value. So again, D is our solution. Which statement describes the function represented by the table below? As x increases by 5, so I should be able to start at any x and go up 1, 2, 3, 4, 5. The y value decreases by 1. Well, my graph isn't going down, so that's definitely not true. As the x value increases by 1, the y value increases by 5. 1, 2, 3, 4, 5. That's not true. As the x value decreases by 1, the y value decreases by 5. That's not true. As the x value increases by 3, 1, 2, 3, the y value decreases by 1. All right. We have a wonderful example of a problem that does not have an answer. Number 13. Complete the tables for the following function. These are your input-output tables. So any of the x values that are given, we can simply plug those x values into the equation. So 5 times -2 is -10. 0 times 5 is 0. And 5 times 5 is 25. Now working backwards, we simply need to take what our y value is and plug it in for the f of x, which we said in class was a fancy way of writing y. So 15 equals 5x. Our x is going to be equal to 3. We'll do the same thing with our 32.5. 32.5 equals 5x, and we'll divide both sides by 5 and determine that our x value is 6.5. G of x is equal to 5/3 x. So again, we're going to take our x value and plug it in. 5/3 times 6, -6 is going to be -10. When we plug a 0 in for x, we're going to get a 0. When we plug a 15 in for x, we'll get 15 over 3 is 5. Times 5 is 25. And now again, we need to set up our equation. Negative 5 can be plugged in for g of x. Negative 5 is equal to 5/3 x, where in order to clear out the fraction, we're going to multiply by the reciprocal, 3/5, and we'll multiply by the reciprocal, 3/5, where that will simplify. And over here, this will simplify, and we end up with negative 1 times 3, which is negative 3. We'll do the same thing with our 35. 35 is equal to 5/3 x. So we're going to again multiply by 3/5. Where 5 will go into 35 7 times. So 7 times 3 is 21. And we filled out the table. Now the last one. No longer in direct variation form, but that's okay. We can still handle it. We plug the negative 2 in for x. Negative 2 squared is 4 times 5 is 20 minus 3 and gives us 17. 0 squared is 0 times 5 is still 0 minus 3 is negative 3. 5 squared is 25 times 5 is 125 minus 3 is 122. Now, in order to work backwards, we need to simply plug in the values. So 17 is equal to 5x squared minus 3. We'll add 3 to both sides. 20 is equal to 5x squared, so we'll divide by 5. 4 is equal to x squared. We take square root of both sides, and x is equal to positive and negative, 2. So on my x value here, we're going to have both positive and negative 2. Now, we should have already known negative 2 to be a solution because we had the 17 up here. So really, I don't need the negative down here anymore because we already have that listed as an ordered pair, but it's probably a good practice to go ahead and recognize. And it doesn't hurt for us to have a negative 2, 17 ordered pair more than once. Same process for our 77. 77 is equal to 5x squared minus 3, where we add 3 to both sides. 80 is equal to 5x squared, so we'll divide by 5. And 16 is equal to x squared, so x is equal to plus or minus 4. So again, plus or minus 4 will be our solution. Now, use the functions above to answer the questions below. We should recognize that we have an f of x, a g of x, and an h of 8x function. So our first problem asks for f of x being equal to 120. So since f of x is a fancy way of writing y is equal to 120, or we already know that the f of x is equal to 120, so we can plug it in for f of x. We end up with 120 is equal to 5x, where x is equal to 24. So f of 24 is equal to 120. B says g of 5. Well, g of 5, we're going to use the g of x function. G of 5 is equal to 5/3 times 5, where 5 times 5 is 25 over 3, and that won't simplify at all. So g of 5 is equal to 25 over 3. All right, h of 1/2. So we're going to plug that in for x. H of 1/2 is equal to 5 times 1/2 squared minus 3, where 1/2 squared is 1/4, so we end up with 5 times 1/4 minus 3, which is going to give us 5/4 minus. In order for us to subtract, we need to have a common denominator. So 12 over 4, which is going to give us negative 7/4 equals our h of 1/2. Oh, sorry. And then D. D is our compound. We have a f of 3, a g of 0, subtracting an h of 5. So we have a couple of steps we need to figure out here. F of 3 equals 5 times 3. So f of 3 equals 15. A g of 0, well, the nice thing about a g of 0 is if I plug a 0 in for my equation up here, 0 times 5/3 is 0. So we can go ahead and say that our g of 0 is equal to 0. Minus an h of 5. Now, I have two options here. First, I can look at my table because we already realized from the table that I've plugged in the h of 5 and done that once before. Second, I can do the whole process again and treat it like an individual problem if I don't realize that we already have an h of 5 listed up there. Now that we know our f of 3, our g of 0, and our h of 5 value, we can simply plug them back into the original operation. F of 3 is 15, plus g of 0 is 0, minus 122. So we have 15 plus 0 is 15 minus 122 is equal to negative 107. And that's our solution.